All right, thanks for bearing with us. We are ready to start. My name is Aaron Timmons. Welcome to our second AP Calculus AB content review session, originally scheduled from February 6th, rescheduled to today, but we are excited to have you all back with us. We are going to go over just a couple of quick screen sharing slides here. We'll get started right away. So today we are joined by Danielle Meyer. She is from Scott High School in Taylor Mill, Kentucky. She's going to be presenting on Unit 4, Differentiation Applications, as well as big theorems. So that would be mean value theorem, IVT, and EVT. So all of those things will be covered today. All right, next. So quickly, this review session is intended for Kentucky audience. However, I realize lots of you are here from out of state, so welcome. We are happy you are here. We will make every effort possible to engage you as much as possible. Any participant causing a disruption will be removed. And furthermore, AP is a trademark registered by the College Board. They were not affiliated with or endorsing of this product. Today, our hosts, we're Advanced Kentucky. Give us a follow, look us up on Twitter, Facebook. Again, my name is Aaron Timmons. I'm the content director for math. Email, Twitter, right there. Reach out to me, tweet, whatever you all like to do on social media. Meeting etiquette, your microphones and videos are off today, but your chat is open. So please ask questions via the chat. We'll have a couple of Zoom polls. So please utilize the chat. If you are a teacher, if you are a student, any question, fair game, we will put those out to Danielle and she will get back to us right away. A recording of today's session will be posted by Monday to the website that you used to register, which was the bit.ly/ADVKY website. Also, recordings of all of our other sessions, as well as science sessions, are going to be up there as well in computer science. English sessions are going to be occurring later on this semester, so please look those up and give us some views. All right, so with that said, I'm going to stop sharing. Danielle's camera does not work, but she is here via audio and she'll be able to share her screen, so I will let her introduce herself. You'll not get to see a face of her, so you'll just have to imagine. So Danielle, without further ado, it's all you.
Hello, everybody. I think we're finally going to figure out how to work this thing out today. So welcome. And I do apologize for the last time, the inconvenience. So I should be sharing my screen here in just a second. We are going to jump right into differentiation applications. And this is a pretty giant unit. So I've done my best to try to condense it down to the topics that I think are most important and that show up most frequently on the AP exam. So to get started, these are the topics that we're going to talk about today. Average rate of change versus instantaneous rate of change, related rates, and particle motion with respect to differentiation. All right, so let's get started with AROC versus IROC, average rate of change versus instantaneous rate of change. Okay, so the things that we need to know here, we're going to refer to this as AROC. Average rate of change is slope over an interval. Slope on an interval. So this is when you have two endpoints and you can calculate slope over that interval. Whereas instantaneous rate of change, or IROC, would be slope at a particular point. The rate of change at a point. Okay, so we have different ways of approaching or finding these two rates. An average rate of change is really just a slope formula. F of B minus F of A over B minus A. And a lot of my kids like to call this baby slope. Whereas instantaneous rate of change is the derivative. So you need an equation to find the derivative of, and then you'll have an X value to plug into that derivative. Okay. One more note that I want to put is average rate of change is often used to estimate instantaneous rate of change. And we'll see that on the AP exam quite frequently. All right, so let's see if we can take this information and apply it to a few examples. So this first one here says, grass clippings are placed in a bin where they decompose. For t between 0 and 30, the amount of grass clippings remain in the bin is modeled by A of t, where A of t is measured in pounds and t is measured in days. Part A says, find the average rate of change over the interval from 0 to 30 and indicate units of measure, average rate of change. So anytime I see that, I automatically think f of b minus f of a over b minus a. All right, in this case, our function is called a of t, and we're on an interval from 0 to 30. So we're really going to be looking at a of 30 minus a of 0 over 30 minus 0. This is a graphing calculator question, so I'm going to use a TI-84 app I have on my iPad that looks very similar to a handheld calculator that you will have access to, hopefully, on the AP exam and hopefully today as well. All right, so a couple calculator skills. We all need to make sure we can enter fractions into our calculator. So we're going to push alpha y equals and enter. And I'm going to enter in my equation as I had it on my paper, a of 30. So my a function was 6.687. In parentheses, I'll have 0.931, and this would be raised to the 30th. Minus, now I have to evaluate the function at 0. Divided by 30 minus 0. Now, a lot of you may have realized that anything to the 0 power is 1, so you didn't need that. I also didn't need to put the minus 0 in the denominator, but I kind of want to make sure that we're all on the same page and everybody knows what I'm plugging in and why. Little enter gives me negative 0.197 if I'm going to round. So I'll go back to my problem. So again, approximately, my little squigglies aren't showing up, negative 0. I think I might be frozen. Oh goodness. Okay, well that would be negative 0.197. The units, a lot of my students have trouble with units here. So we just need to think about the context of the problem and the units that we're dealing with here. So it tells us that a of t is measured in pounds and that t is measured in days. So in my fraction in the numerator is my a of t, that would be pounds, and my denominator was time, so that would be days. So pound per day would be my rate here. Sorry, it looks like something is going on with my iPad. I'm going to close this out and try to restart it because it was not letting me write for some reason. I've actually haven't had that issue. Let's see. No.
Danielle, someone suggested in the chat, if you stop sharing and then reshare, your iPad may catch up.
Okay, I thought that'd be what's going on. So do I stop that on my laptop or my iPad?
Just stop sharing on your laptop.
Okay. You know, we always use Google Meets at my school, so I've figured out all of the strategies for fixing tech on that, but I haven't been able to work with Zoom.
All right, see if you can start sharing again.
Okay. Okay. Let's see, does it let me write? Yay. Thank you, Kayla. All right, so negative 0.197 pounds per day. For part B, it's asking for a prime of 15. So this is our instantaneous rate of change. Okay, so instantaneous rate of change comes from the derivative. And this is a calculator question, so we don't have to do anything by hand. We just have to find a prime of 15 on the calculator. So if you use your calculator to do that, we'll push math 8. My function is 6.687 times 0.931 raised to the, I'll say x power, and we want to evaluate this in x is 15. So I get negative 0.164. So I just don't think it's liking that I'm changing from apps when I'm sharing. So I might not be able to show what I'm doing in the calculator. That might be the issue here, because we don't want to have to unshare and reshare every time.
Yeah.
I go, okay.
Here.
So now that I know that that's what's causing it, let me try this again.
Right there. So yeah, you can just kind of guide us through what you're putting into your calculator.
Yeah. Okay, so let me try to share my screen again. Okay, so you should have, let's see. Here we go, negative 0.164. And just like our average rate of change, our units are going to be pounds per day. This one actually asks for you to interpret the meaning of the value in the context of the problem. So since our derivative is negative, that means that we have a decreasing rate. So we would say the amount of grass clippings are decreasing. Pretty important word there. If it had been a positive, I would have said increasing by a rate of, now I already used the word decreasing, so that is taking care of my negative. So I'm just going to say by a rate of 0.164 pounds per day. When, well, we plugged in 15, so at t equals 15 days. Okay, average rate of change versus instantaneous rate of change. One is from a slope formula and one is from the derivative. Okay, so let's go ahead and look at another type of question they can ask you. So this one, they give you a table of values, and from the table, you can see they're giving you a W of T values, which are in degrees Fahrenheit, and T values, which are in minutes. And it tells you a lot of information in this question because it was part of a free response question. We are only dealing with part A though. So it says use the data in the table to estimate W prime of 12. So remember on that first page, I said that we used average rate of change to approximate our instantaneous rates of change quite frequently. So this is really an AROC question. And this is common in a table question. So they're wanting us to approximate W prime of 12. And in our table, you notice we actually in this problem don't see a 12, but I know that 12 would actually be in between these two values. So how do we calculate slope? We need 2 points, and luckily they have given us 2 points, so we can do that. So we can say W prime of 12 is approximately, well, it would be W of 15 minus W of 9 divided by 15 minus 9. Now that step is not necessary. You can jump right in with the numbers from the table, but again, I'm just trying to be a little thorough so people know where I'm gathering this information from. So W of 15 was 67.9, W of 9 is 61.8, and then we would divide by 15 minus 9. And so in our calculator, we can type that in, and if you do, you should get 1.017. Okay, so that was part of the question. The second part of the question says, using correct units, interpret the meaning. And for some reason, a lot of students like to kind of skip over this part of the question. So let's think about what it's talking about. So W of T is water temperature, and we're calculating the rate of change. We got a positive answer, which tells me my rate is increasing. And we can figure out our units pretty easily just by looking at where our numbers in the table came from. So our 67.9 and 61.8 were degrees Fahrenheit, and 15 and 9 were minutes. So my units on this guy would be degrees Fahrenheit per minute. Okay. And then we can use that in our explanation or our interpretation of what this means. So I would say the water temperature is increasing at a rate of what do we get? 1.017 degrees Fahrenheit per minute. And a really important thing that people often leave off is it's not always increasing at this rate. This was specifically used to approximate what was happening when T was 12 minutes. So we want to make sure we add that in. All right, so let's see if you can try a couple of these. So we have our first Zoom poll. It's a multiple choice question.
So
Says
with
the temperature. Go ahead.
Oh, sorry, go ahead.
Oh, I was just going to read the question to them, but I don't really need to. So go ahead.
So with the Zoom polls here, take a few minutes here or a minute, work out the problem. Then we will start the Zoom poll. When the screen pops up, you might need to drag it out of the way so you can see it better. But we will open the poll, and it's anonymous. So please give us your best answer, and then we will go over the responses. So take a few seconds here, then I'll put the poll up. All right, so you should see a poll on your screen. Again, if you're still working on the question, just drag that window off to the side and then put in your response here. Once we get a decent number of responses, we will go ahead and end the poll and then show the results.
Aaron, do you know how many people we have? Oh, never mind. I see the number now. It's a pretty good turnout.
So we'll take about 1 more minute here. Get your responses put in. We're up to about 40%, so we want to get a little higher than that, please.
I will say if you're using your calculator and anybody's taken the ACT recently, you will want to make sure that you're in radians.
All right, we'll go ahead and end the poll here.
Okay.
And then here we'll share the results, and Danielle, you can speak to the results here that are going to show up on the screen.
Yeah, so the correct answer is B. And how I would do this is it's asking for instantaneous rate of change, which comes from the derivative. And it's a calculator question. So I would simply do math 8 on my calculator, and I would enter in this function and evaluate that when x equals 90. And as long as you're in radians, you should end up with 0.153 degrees Fahrenheit per day. So B is the correct answer here.
And this question was tricky simply just because of all of the parentheses you'll need if you're putting into the calculator.
Definitely. All right. So here is another one with a table. Go ahead and take a minute for this one, and we can restart a poll.
So you can just drag that window off to the side if you need to, so you can finish working the question. All right, we'll take about 30 more seconds. All right, so here are the results. Danielle, you can reveal the correct answer.
Yeah, the correct answer is B. So we did much better on this problem. Just to show the setup for the people that need it, we should do f of 10 minus f of 0 should be negative 20 minus 5 over 10 minus 0, or over 10, which will reduce to negative 5 halves. Do we just exit out this of the Zoom poll? I think I'm actually going to skip the next one just to move on to the next topic because we did get started a few minutes late.
All right, that's fine.
Okay, so let's go ahead and switch gears and talk about related rates.
And let me just interrupt just for a second.
No.
Sorry, Danielle.
Just
remember, if you have any questions, feel free to put those in the chat. You can direct them specifically to me, and I will get those to Danielle, or you can put them in the chat to everyone. But if you have questions, please do not be hesitant to ask.
Definitely. All right, so for related rates, so we have two related variables that are changing with respect to time. So what related rates require is for us to differentiate implicitly. What does that mean? Well, that usually means you have x's and y's in an equation, and we have to remember when we find the derivative of a y, we get dy dx. The derivative of y is dy dx. Okay. Another thing I like to remind my students of is that we need to do some calculus before we can do some algebra. So a lot of times the first instinct is just to go ahead and plug in a bunch of numbers. You can only do that with things that are constant. If things change at all, you'll need to do calculus before you can plug in. Okay. And then a lot of times we just get kind of confused with all of the different variables there are. So for example, if a question is talking about the rate of change of area, well, the rate of change, that means it's a derivative of area. So I would have dA dt for that. Similarly, you could have like the rate of change of volume, we would use dV dt, or the rate of change of x, we would have a dx dt. So we try to name things appropriately. Okay, we also need to know if a rate is decreasing, that means that we're going to have a negative value. So sometimes they might give us a number in a problem and saying it's decreasing at that rate. So we need to make sure that we insert that negative when appropriate. And then increasing would be a positive rate. So let's see if we can go ahead and define some variables, because that tends to be the most difficult thing for my kiddos. So it says an ice sculpture in the form of a sphere melts in a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate. Volume is decreasing at a constant rate of -2 cubic meters per hour. It's probably going to be important. And it says, at what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters? Okay, so I kind of like to go through these like line by line and pick out the important pieces of information. So the first thing I highlighted was about volume, and it was talking about decreasing at a rate. So we're talking about the rate of volume, which means I need a derivative, dV dt, the rate of volume. They told me it was decreasing, so it's going to be negative, and it said it was 2 pi meters cubed per hour. So I know dV dt is -2 pi. Okay, the next line, if I read that, says at what rate, so it's asking me for a rate of surface area, the rate of surface area. So I need a derivative of surface area. So I would call that maybe dA dt for area. And it's asking me what is that? So I don't know what that is. I'll put a question mark there. It's asking what is that rate when r equals 5. Now note, r does not always equal 5. R is going to be 5 at a specific point in time. So we're going to have to wait to plug that information in until after we use some calculus. Okay, so luckily they give us two equations. They give us an equation for surface area, and they give us an equation for volume. Okay, so I'm not really sure which one you want to start with. I know I'm trying to find ds dt. They gave me dV dt for some reason. So maybe let's start with volume. So they say volume is 4/3 pi r cubed. All right, so let's start by differentiating that equation. So the derivative of v with respect to t would be dV dt. On the right-hand side, that 4/3 pi is a constant. So my variable is r cubed, and I'm differentiating with respect to time. So I'm going to multiply by that power, which is 3. I'm going to leave my constant multiplier, let it go along for the ride. When you find a derivative, you subtract 1 from the exponent, so that's going to become r squared. And because we're differentiating with respect to time, I need my dr dt. Derivative of r with respect to time is dr dt. All right, so when I look at this equation, I realize I know what dv dt is. They told me that information, right? We also know, we know what r is, but let's go ahead and simplify this real quick because I think we're going to see something pretty interesting. So these 3's will cancel out and I'll end up with 4 pi r squared dr dt. I think the really cool thing here is this guy right here, 4 pi r squared. They actually told me that that's the formula for surface area, which is why math is so cool. Okay, so then what can I do with this? Well, I think we can plug in our information. We know dv dt is a negative 2 pi. We know r is 5. And it looks like we do not know dr dt, but that's okay because it's our only unknown right there. So we should be able to solve for that. So if you divide both sides by 4 pi times 25 or 100 pi, you will get negative 1 over 50 for dr dt. Okay, now that didn't exactly answer my question, did it? Because our question is not asking for dr dt, our question is asking for dA dt. So how in the world is this going to help us out? I think if we switch gears and jump over to our area equation, we might see how this is useful. So let's go through the same process with this equation that we did with our volume. So if I want to find the derivative of A with respect to t, I will get dA dt. Then I will find the derivative of 4 pi r squared. My 4 pi is just a constant. It will go along for the ride. So I will multiply by my exponent, my 2 in this case. And then if we subtract 1 from the exponent, that just becomes r. And I can't forget my dr dt. So this right here is why we needed the other equation to begin with, because they never told me what dr dt is. Now that we've found it, we can simply plug in. So we have dA dt equals 2 times 4 pi, and you could go ahead and write that as 8 pi if you'd like. R is 5, and we found dr dt was negative 1 over 50. So in a calculator, I would do 2 times 4 times 5 times a negative 1 over 50. And then realize that all of these answers have a pi in it. So there's no reason to put the pi in your calculator. If you do that, you will get 4 pi over 5. Does anybody have questions on that one? Because I know that was a multi-step related relates problem. If you did not know to start with volume, you easily could have started with area as well, and you would have gotten stuck. You would have gotten down to a dr dt and realized you didn't have information to plug in for that. And so then you could have switched gears and worked with the volume equation to get that number as well.
Danielle.
Yeah.
We had a good question. I was just waiting for it.
Yeah.
What happened to the negative sign?
What happened to my negative sign? Where?
Well, when you did the dA over dt, you had a negative for the negative 1 over 50, but yet none of the answer choices have a negative. Can you explain where that's being taken care of, though?
Yeah. It says, at what rate in square meters per hour is the surface area of the sphere decreasing? So it's asking for the rate that it's decreasing. So the negative is taken care of by the decreasing.
Yeah. Thanks.
Perfect. Good question.
Yeah.
Do we have any others?
None on my end.
Okay. All right, so that was one type of related rate where they give you the equations. There are also some related rate problems where you're expected to figure out the equation on your own. So here is an example, and I think we're actually going to see two problems dealing with this same situation where we're going to need different equations because they're asking for different pieces of information. So this one says we have a ship A traveling due west. Okay, so I like to draw arrows because that kind of in my head lets me know direction. This ship is going that direction at a speed of 15 kilometers per hour. Ship B is traveling due north. So here's ship B traveling that direction. Let X be the distance between ship A and the lighthouse. Let Y be the distance. They have this labeled for us, right? They're just telling us this information in words. And they're asking for us to find the rate of change of the distance between the two ships. So they're giving us an X, a Y, and they're asking about a Z. So I can see that we have a right triangle and we are dealing with three sides of this right triangle. What equation do we know that relates all three sides of a right triangle? Hopefully we all know it's the Pythagorean Theorem. Okay, and this can work with any variables that you choose to call them. We're dealing with X, Y, and Z in my equation. Okay, so now that we have a basis for what we're going to be dealing with, let's go ahead and identify our variables as well. So it's kind of confusing because they're talking about ship A, but then that's the X side of the triangle. So if you want to make those all the same variable, that could be a good idea as well to make sure that you're identifying things correctly. I'll go ahead and stick with X, Y, and Z. So in the west direction, it tells us a speed of 15 kilometers. Okay, so we do have to remember that if we're going west or left, then that would be a negative rate of change. So I'll say dx dt is equal to a negative 15 kilometers per hour. Okay, what about dy dt? How fast are we going north? Ship B is traveling due north at a speed of 10 kilometers, and north would be a positive. They had said south, we would have made that a negative as well. We obviously don't know what dz dt is because that's what they are asking us for. And then in my problem, they give me more information that X is 4, Y is 3. And if we're dealing with a right triangle where one leg is 4 and the other is 3, then I'm thinking a lot of us might realize that my hypotenuse has to be 5. 3, 4, 5 triangle. And if not, you could easily set this up and solve using Pythagorean theorem to figure out that it's 5. Okay, so let's start with our Pythagorean theorem. X squared plus y squared equals z squared for our problem. And we have to remember, we can't just plug x, y, and z in because we need to talk about their rates. So we need to find a derivative with respect to time. So the derivative of x squared with respect to time would be 2x dx dt. And the derivative of y squared with respect to time would be 2y dy dt. And then similarly, the derivative of z squared would be 2z dz dt. If you can get that far, it's going to be a matter of plugging in. So let's see, what did they say x was? X is 4. We identified dx dt already as a negative 15. Y is 3, so we'll have 2 times 3, and we identified dy dt as 10. Z is 5, and we do not know what dz dt is. That is what we are trying to find. All right, so I would simplify the left-hand side of the equation in my calculator and then divide that by 10 to solve for dz dt. And if you do that, give you a second to check your work, you should get -6. And we'll have the same units, kilometers per hour. So Pythagorean Theorem example is kind of like a classic relative rates example, very common in AP Calculus and on the AP exam. All right, so let's kind of see if we can deal with the same situation, but change gears a little bit. So same prompt. So we're going to have the same variables that we started with, the same rates, but this time they're asking us about theta. So instead of relating all three sides of a right triangle, this time we have to involve an angle, which means I'm going to need a trig function. Now, this example particularly, we do have some options because of the problem that we just worked out. We found dz dt, so we can deal with the hypotenuse. I'm going to pretend like we haven't done that yet, though, because if we're on the AP exam, you might not get these problems sequentially, and you won't want to have to like do an entire separate related rate problem before you start this one if you don't have to. Okay, so I'm going to kind of pretend like I don't know anything about z right now. So looking at this triangle, with that in mind, it looks like I have the opposite and the adjacent sides of my triangle. And according to SOHCAHTOA, hopefully we all remember that, if I'm dealing with opposite and adjacent, then I need to talk about tangent. So according to my picture here, tangent of theta is equal to opposite, which would be y, over adjacent, which would be x. So tangent of theta equals y over x. All right, so then let's see if we can find a derivative. Do you remember what the derivative of tangent is? The derivative of tangent is secant squared. So we'll have secant squared theta. Derivative of theta with respect to t would be d theta dt. And then on the right-hand side, we have y over x. We have a fraction, which means that we're going to need the quotient rule. So quotient rule says we have to take our denominator and multiply by the derivative of our numerator. So the derivative of y with respect to time would be dy dt, minus our numerator, our y, times the derivative of the denominator, dx dt, all over the denominator squared, or x squared in this case. All right, so we found the derivative. So let's go ahead and plug in all the information that we do know, or that we can figure out. So for example, secant of theta, we should know that secant is the reciprocal of cosine. And according to SOHCAHTOA, cosine is adjacent over hypotenuse, which would mean secant would be hypotenuse over adjacent. Notice that they're still dealing with the same triangle, x equals 4, y equals 3. So that would mean that my x here would be, my adjacent here would be 4, and my hypotenuse would be 5. So hypotenuse over adjacent would be 5 over 4. That's what secant is. Now we still need to square that. We do not know anything about d theta dt. That's what we're trying to figure out. And then on the right-hand side, we already know these values, the rates and the side length. So x was 4, dy dt was 10, y is 3, and dx dt is -15, all over x squared, or 4 squared. Okay, so we just need to simplify. I'll kind of come down here so I have more room. So we have 25 over 16 d theta dt equals, if I were you, I would plug all of this into my calculator at once. I can't switch to my calculator app though, unfortunately, to get one answer on the right-hand side. And then you can divide both sides by the 25 over 16, or multiply by 16, divide by 25. And in the end, you should end up with 17 over 15. And then they tell us it's radians per hour. It's also a good idea to be able to figure that out on your own. So d theta, well, theta should always be measured in radians in calculus, and time in this question is measured in hours. So even if they didn't tell you radians per hour, we should be able to figure that out as well. Okay, I know related rates are hard, but we're going to give this a shot anyway. So we have one problem for you to try on your own. So the radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. In terms of circumference, what is the rate of change of area of the circle? So I do want to talk about two things first, just to make sure everybody has the tools that they need to be able to solve this. So we need two things. We need the formula for area of a circle and circumference of the circle. So area is pi r squared and circumference is 2 pi r. And those are equations that AP expects you to know. But go ahead and take a minute and see if you can work out this problem. And then Erin, can you activate that Zoom poll? All right, I'll give you a few more seconds to try to finish up this problem before we talk about it.
All right, we'll go ahead and end the poll here.
Okay.
So here are the results.
Yeah, so it looks like a real mixed bag here. And these are hard questions, right? So B is the correct answer, and that did win. So that's good at least. Let's go ahead and go over this one though. So it says the radius of the circle is decreasing. That lets me know it's going to be a negative. A rate of 0.1 centimeters per second. So the radius, so that would be dr dt. Decreasing is a negative, and we have 0.1 centimeters per second. In terms of circumference, what is the rate of change of area? So they're asking to find dA dt. Okay, so that means I'm going to start with the equation for area because that's what they're asking about. Pi r squared. I'm going to see where that takes us. So we'll start by finding the derivative. Well, the derivative of A with respect to t would be dA dt. Remember, pi is just a constant. It's going to go along for the ride. So pi r squared's derivative would be 2 pi r dr dt. Okay, then I'm hoping a lot of you notice now that we have a 2 pi r just conveniently sitting there. And 2 pi r is actually the equation for circumference. So since this question asked in terms of the circumference, what is the rate of change? I'm going to go ahead and relabel that as C. So we can have dA dt equals C times dr dt. And then we can plug in the information that they gave us. We figured out from the problem that dr dt is a negative 0.1. So this would be C times negative 0.1. Or you can write that in the opposite order, and you see that our answer is B. All right, so that is it for relative rates. We are going to move on to motion, but we are going to take a brief break before we start that.
So yes, we will take about a 5-minute break here. When we come back, Danielle will finish up covering some PVA before moving on to big theorems. So take a couple minutes here. We will resume at about 10 after 11. If you have questions, put them in the chat. We will get to those as well. Take a break, and we will see you back here in about 5 minutes. Danielle, I did have a question though for you here before.
Oh yeah, sorry.
Can you go back to the slide that you had with the, I think it was the last trig one. It was the where you had 17 over 15 for your answer. Yeah, we had a person that wanted to look at that work because they didn't get the same answer. So you can just leave that up here for a second. Then they have a question.
I will leave it up for during our break.
All right, sounds good. All right, it is 10 after. We are going to pick back up. Danielle's going to finish up with particle motion and then move on to big theorems. So Danielle, back to you.
All right. And I just wanted to say I did write the wrong answer down on this problem. It was 17/5. I think I had 17/15. I do apologize for that. And nice catch for whoever that was. Okay, so we're going to talk about motion, and there's a lot to motion, and some of it involves integrals, and we're not going to talk about any of that right now because we're dealing with differentiation specifically. Okay, so the first things I want to kind of talk about is like how we name functions and then some characteristics. So for position, these are usually referred to as x of t or s of t in a problem. Velocity would then be v of t for velocity, or you can take the derivative of x of t, so x prime. And then acceleration, we often use a of t, or that would be the second derivative. Okay, so position, velocity, acceleration. Okay, if a problem tells you that something happens initially, then that they are saying that it's at the beginning, or t equals 0. If you see at the origin, then they mean the position function is equal to 0. At rest would mean the object's not moving, so the velocity function is equal to 0. And then they can ask about average velocity or average acceleration. And depending on the type of information that you're given, this could also be an average value problem, and we're not going to be dealing with those today. So average velocity, when you were given the position function, is just average rate of change. So this would be like AROC, which we've already talked about today. And then average acceleration, if you're given the velocity function, just the rate of change of velocity. Now, remember, if you're given velocity and asked for average velocity, then it's going to be an average value problem. And that's going to deal with integration. Okay, on the right-hand side of the screen, if your velocity function is greater than 0, that means it's positive, then you are moving, your particle is moving either right or up, depending on whether they tell you you have vertical or horizontal movement. And if velocity is negative, then you're moving left or down. If acceleration is positive, then that means that your velocity is increasing, because acceleration is the derivative of velocity. And if acceleration is negative, then velocity would be decreasing. We do need to know that speed is the absolute value of velocity. And the last two things, if A of t and V of t have the same sign, so if they're either both positive or both negative, then the particle or the object is speeding up. Forces are working together. However, if A of t and V of t have opposite signs, if one is positive and one is negative, then the object is slowing down. And this is a common question that gets missed on the AP exam because students tend to either just look at velocity or just look at acceleration to try to explain it, and you really need both entities.
Can you scroll back up just a little bit, Danielle, please?
Yes. All right, so this is going to be like our reference sheet or information page. Hopefully, when we look through our problems, we can kind of reference this page to figure out what it is we're supposed to be doing. Give you a few more seconds and then we'll try to do some problems. All right. So this example says a particle moves along the y-axis, so it's moving vertically, and it gives us a velocity function v of t for t greater than or equal to 0. Part A says, in which direction, up or down, is the particle moving at t equals 1.5? So if we look at our reference sheet, we want to know if we're moving up or down. That would be dealing with our velocity, whether our velocity is positive or negative. So that means I need to plug 1.5 into my velocity function and figure out if that's positive or negative. So we are going to do v of 1.5. So in your calculators, you're going to type in 1.5 sine of 1.5 squared. When I type that in, I get approximately 1.167. Now, the value that I get isn't important. The sign of it is what is important. And I notice that this is a positive number. So if my velocity is positive, then the particle is moving up. And how did I know that? Well, because v of 1.5 was positive. And that sentence answers the why as well. So particle is moving up because v of 1.5 is greater than 0. For B, it says find the acceleration of the particle at t equals 1.5. So let's do that first, and then we can answer the second part of the question. Acceleration at 1.5. How do we do that? It's a calculator question, so I simply need to do math 8. So if you haven't been practicing this yet, this is a great time to try. So on your calculator, you'll do math 8, and then you'll enter in your function. And we're trying to evaluate this at 1.5. So after the function, you'll say x equals 1.5. When I enter this into my calculator, I get negative 2.049. Negative 2.049. So that was the first part of the question. Then it asks, is the velocity of the particle increasing at t equals 1.5? Why or why not? So they made you find a of 1.5 for a reason. They want you to use that to answer the second part of the question. So if you're not sure, we can go back up here and see how these things are related. Remember, we found acceleration and they're asking about velocity. So if acceleration is positive, velocity is increasing, and if acceleration is negative, velocity is decreasing. Well, we got a negative acceleration. So I know our velocity is decreasing. So I'll say the velocity is decreasing because, well, we knew a of 1.5 was negative or less than 0. And you can write out is negative if you prefer. Okay, so that was examples that came from free response. One asked about direction and one asked about velocity increasing. The next example is a multiple choice example. So say particle moves along the x-axis. So we have horizontal movement this time for t is greater than or equal to 0. Its position is given by x of t. At what time is the particle at rest? Remember, at rest means that you're not moving. And if it's not moving, that means the velocity is 0. At rest means velocity equals 0. Okay, well, they gave me a position function, but I need to look at the velocity function. So we just need to differentiate. So the derivative of position is velocity. And luckily, the position function is a nice polynomial, so the derivative is not too complex. So the derivative of 2t cubed, if we multiply by that 3, we get 6t squared. The derivative of negative 21t squared would be a negative 42t. Derivative of 72t would be 72, and the derivative of negative 53, or the derivative of any constant, is just 0. So this is my velocity function, and I want to know when that equals 0. This is a non-calculator question, so we do have to solve this by hand. I have a polynomial, and I have more than one t variable, so chances are I'm going to need to factor. So when I look at this, just like all factoring problems, I always try to find a GCF first. And I notice that all of these numbers are divisible by 6. So I will start by factoring out a 6 from each term, which will leave me with t squared. 42 divided by 6 is 7, so minus 7t. And 72 divided by 6 is 12, so plus 12. Okay, what I have left here is a trinomial, and trinomials factor into two binomials. So I'll set up my parentheses. T squared splits into t, and 12 can split into 3 and 4 because negative 3 and negative 4 add to negative 7. And then by setting each of these factors equal to 0, you find that t is equal to 3 and 4 are our options. So our answer would be E. Okay, we have one more together. The particle moves along a straight line. The graph of the particle's position is given by the graph above. It's asking for when the velocity of the particle is increasing. And we actually already dealt with a question like this where the velocity of the particle is increasing. And we used acceleration to figure that out. Right? It just looks a little bit different when we're thinking about a graph. So we need to know when A of t is positive. On a graph, we have to remember that acceleration is the second derivative. And the second derivative tells us about concavity. So if acceleration or the second derivative is positive, we need to look where our function is concave up. So since they gave us the graph of our x of t function, of our position function, we're just looking for where this function is concave up. So that looks to me to be the interval from 0 to 2, which is A. All right, I've got a couple for you to try, and then we will get through some theorems. I actually think I might skip this first one and just do Zoom Poll 6. So take a minute, read through the question, and see if you can come to an answer.
All right, we'll take about 30 more seconds here for people to get their responses in. All right, so there are the responses. I'll share those in a second. And then Danielle, you can talk about what you see.
All right, so on this one, they gave you velocity and asked for acceleration at time t equals 4. It was a calculator question. So you needed to know that acceleration is just the derivative of velocity. So you needed to find the derivative, evaluate at 4, and you could have done that with Math 8. If you did, you should have gotten C, which was the winner here. If not, I would just check to make sure that you're using Math 8 and you plugged everything in correctly, and you should get C, 1.633 for your answer. All right, I am going to switch over and talk about theorems. So if you printed these off, this is the second packet, big theorems. Okay, we're going to go through intermediate value theorem, mean value theorem, and Rolle's theorem, which is just a special case, and extreme value theorem. And we're just going to take these one by one and kind of work through them. So we'll start with IVT, which is technically like a pre-cal theorem. You don't need really any calculus to be able to do IVT, except for maybe the word continuous, which sometimes doesn't get introduced until calculus. So on the left, you can see I have the theorem. I also have a nice picture for you. IVT says if f of x is continuous on the closed interval from a to b, and k is any y value between f of a and f of b, then there exists at least one value c, an x value, between the two endpoints such that f of c equals k. Okay, so what does this mean? A lot of kids have a hard time interpreting math talk. So it's just saying on a continuous interval or on a continuous function, you will hit or obtain every y value. On a continuous function, you will obtain every y value between two given y values. At least once. Can be more than once. At least once. On a continuous function, you will hit every y value between two given y values at least once. Okay. So they could give you a y value of -3 and a y value of 5. And if you connect those two values, you're going to go through 0. You're actually going to go through every number between those two. Okay. Important to note for IVT, it shows up quite frequently on free response questions, and you must state a function is continuous to use IVT. I've been told even if the problem says specifically the function is continuous, you still need to state it. You explaining that you understand it's a condition of intermediate value theorem. So let's look at a problem with IVT. What does this look like? So it says let f be a twice differentiable function such that f of 2 equals 5 and f of 5 equals 2, and let g be the composite function f of x. That was just the problem stem, right? Because this is a free response question. We might not even need that. Our specific question gives us a function h that is f minus h, or sorry, f minus x. Explain why there must be a value r between 2 and 5 such that h of r is 0. Students often have a hard time trying to figure out which theorem they should be answering a question about. So I always tell them to look for what kind of value they're being asked for. This is just a y value. It's just an original function, no calculus involved. So that means that we're going to need intermediate value theorem, IVT. If that had said h prime instead, we would be talking about a different theorem, and we will actually see that happen here in a minute. Okay. Well, it might help if we knew any y values on h. So far, all we know is the problem stem, they give us some f values. They don't give us any h values, and they're asking us about h. So that's the very first thing we need to do, is we need to look at the interval that they give us, and we need to find what those values are. So we need to find h of 2 and h of 5. Okay. Well, my function h of x is equal to f of x minus x. So I'm looking for f of 2 minus 2 and f of 5 minus 5. Luckily, they tell us that f of 2 is 5 and that f of 5 is 2. So by substituting those in, we can get two y values. For h of 2, we get 3, and for h of 5, we get -3. So we're going from y values of 3 to -3, and it just so happens that 0 is in between those two numbers, so we definitely have to obtain 0. All right, this is free response, so we need to be able to write a statement. Well, IVT requires your function to be continuous. Is h continuous? Well, they tell me that f is twice differentiable, and in order for f to be differentiable, f has to be continuous. And if f is continuous, that means h is going to be continuous. So I will say, since f is continuous, h is continuous. And that might be a little bit of overkill. You at least have to say h is continuous, but I wanted you to know why h is continuous. So since h is continuous, and, well, we just found out that h of 5 was less than 0. We got a negative answer for h of 5, and that h of 2 was greater than 0. So that will allow me to write this inequality. H of 5 is less than 0 is less than h of 2. Say, so by the intermediate value theorem. And then the beautiful thing about this is we can simply repeat exactly what they said in their statement. There must be a value r between 2 and 5 such that h of r equals 0. There must be a value r between 2 and 5 such that h of r equals 0. So you need to state the function's continuous, provide your inequality, and then say by IVT, and you can repeat the theorem is in the question. There must be value r. So that's an example of what IVT looks like on a free response question. IVT will also show up in multiple choice. All right, so let's take a look at what it looks like for multiple choice. So the table above shows selected values of a continuous function g for x between 0 and 11. What is the fewest possible number of times that g of x equals 2? Okay, again, when I'm looking at this and all mixed in with a bunch of different problems, I think, what kind of value are they asking me for? They're asking me just for a y value. And if they're asking me for a y value, then I'm looking at IVT. Well, what has to be true for IVT? Function has to be continuous. They told me that was true. And then we just need y values less than and greater than 2. Okay. So if I look at the table of values, well, if I am connecting y values from 1 to 2.8, I have to go through 2. And then if I go from 2.8 down to 1.7, I have to pass through 2 again. Okay, then we continue to 1 and then back up to 3.4. Somewhere in there, I'm going to have to pass through 2 again. So that's going to be 3 cases. Okay. Now, we don't know what's happening on these intervals. There could be a lot more fluctuation that we're not seeing. So there could be more instances where g of x equals 2, but there has to be at least 3. All right. So here is another multiple choice example, and I believe my f of x got cut off in my table, so let me go ahead and write that in for you. This should be f of x here. We'll go ahead and start a Zoom poll and give you a minute or 2 to try this problem.
All right, about 15 more seconds here. All right, here are the results.
Okay, looks like lots of people selected both A and B. So let's talk about this one. I'm a visual person, so I tend to gravitate towards graphs. So I'm going to do that. That's what I'm going to do is I'm going to plot these points. So I'm going to plot the point 0, 1 and the point 2, 2. And then this question is asking me for a y value of 1/2. Okay. So with what I have drawn right now, if I were just to connect these 2 points, I actually never go through a y value of 1/2. I only go through the y values between 1 and 2. Since this is a multiple choice answer, you could easily just plot these points at K between 1 and 2 and see which one works. So for example, if we were to plot a point at 1/2 and draw this, well, now I have one solution. But they said that I need to have at least 2 solutions. So that guy won't work. If I plotted anything above 1/2, let's say at 2, well, now I have 0 solutions that go through 1/2. So I'm going to have to pick 0. 1, 0. There we go. So what happens if I draw this graph? If I look at y equals 1/2, I now have two solutions. So sometimes just sketching a little picture can help you out on a problem. All right, so IVT is all about y values. MVT, or mean value theorem, deals with derivatives. Okay, so here's the theorem. If f of x is a continuous function, so it also has to be continuous, on a closed interval AB, but this time there's an extra condition. Also has to be differentiable on the open interval AB. And the only reason that's an open interval is because you cannot be differentiable at an endpoint at a specific point if you don't have points to the left or to the right of them. Then there must exist at least, where did the rest of the theorem go? Let's write it down here. 1c in the interval from A to B, such that f prime of C is equal to f of B minus f of A over B minus A. Okay, so I have a picture here for you, and you can see that we've drawn on the secant line and the tangent line. And if you look, you notice that those two lines are parallel. So it's saying that the average rate of change is equal to the instantaneous rate of change. And that happens anytime you have a continuous differentiable function on an interval. Okay. So what does this mean? So we'll say if f is continuous and differentiable, there is at least one point where the slope of the secant line is equal to the slope of the tangent line. And I always explain to my students this way: if you're driving in a car, your average velocity might be, 45 miles per hour. That doesn't mean you went 45 the entire time, but at some point you did have to go 45 miles per hour. Okay. And it's important to note, if you have a situation like this, where your endpoints are equal, that will force the slope of your secant line to be 0, and therefore you will also have a horizontal tangent line, or a place where your derivative is also 0. Okay, so this is actually the same free response stem that we saw back with IVT, but it was another part of the question. And it says, explain why there must be a value C between 2 and 5, such that f prime of C is equal to -1. So again, they're asking me about a derivative, which is going to let me know I need to deal with mean value theorem, EVT. If they were just asking me about a y value, I would think about IVT. Okay, so what do we need for MVT? We need our function to be continuous and differentiable. They told us that f is twice differentiable. And if f is differentiable, that means f is also continuous. So our conditions are met. So what is true is that our slope of the secant line has to be equal to our slope of the tangent line, or that our derivative has to be equal to our slope. Well, what is our slope? F of 5 minus f of 2 over 5 minus 2. Let's figure out what that is. Okay, they told us that f of 5 is 2 and f of 2 is 5. So by substituting that in, I see I get -3/3 or -1, which is what they're asking me for. We want these things to be equal. Okay. So now all I have to do is like wrap this up in a nice, pretty statement, putting a bow on it. Okay, so I will say, since f is continuous and differentiable, and I guess to be most accurate, I should say continuous on the interval from 2 to 5 and differentiable on the open interval from 2 to 5. By, well, I guess I can say mean value theorem. And then we can repeat exactly what they said, just like before. There must be a value c between 2 and 5 such that f prime of c equals -1. There must be a value c between 2 and 5 such that f prime of c is equal to -1. It looks like we have lots of examples for mean value theorem. So I'm definitely gonna have to skip around because of time. So we will skip this next one. Let's look at a multiple choice question. So this one says a function f is continuous on the closed interval from 2 to 5. That's just a coincidence. It's not always from 2 to 5, I promise. F of 2 is 17 and f of 5 is 17, which of the following additional conditions guarantees that there's a place where the derivative is 0? Okay, so I know if I have two equal y values and I calculate my slope, that I get a slope of 0. Okay, so which theorem deals with our derivative equaling the algebra slope? That would be mean value theorem. So what conditions have to be true in order for mean value theorem to be guaranteed? They already told me that f is continuous. So the other condition I would need would be for f to be differentiable. And it looks like that is C. Differentiable on the open interval from 2 to 5. Okay. Trying to figure out how to condense these. What's most important in 10 minutes? It's probably most important to talk about all the theorems. And then I do have some mixed problems after extreme value. So let's go ahead and skip to extreme value theorem, because I think we'll get to talk about a couple questions that involve all the theorems. So EVT is never actually referenced directly on the AP exam, and you do not have to use EVT in an explanation either. It is convenient to understand what the theorem is, though. A continuous function on an interval attains both an absolute maximum, where f of c is greater than all other f of x's, greater than or equal to, and a minimum where f of c would be less than or equal to all the other f of x values over an interval. Okay, so on this graph here, you can see that this would be our absolute maximum value, and this here would be our absolute minimum value. Okay, so we have both an absolute max and a min. So what does it mean? Every continuous function I'll just say f of x on a closed interval has a highest y value and a lowest y value. Has to be one. Okay, for this one, it's important that you state continuity. If a function is continuous on a closed interval, there is an absolute maximum and there is an absolute minimum value. Now, EVT shows up a lot when you need integration as well. It'll be with like a rate of change question, asking for maxes and mins. You usually have to integrate to find the values, sometimes called the candidates test. We are going to stick with differentiation for today. So let's look at an example. Like I said, that you will never be asked specifically just for EVT, but it will show up in examples like this. So it says f is continuous on the closed interval from a to b and differentiable in the open interval from a to b. Which of the following could be false? So if I'm looking at these, I always try to identify what it is exactly that they're talking about. So the first one says that the derivative or the slope of the tangent line is equal to the slope of the secant line. So this is mean value theorem. On B, it says the derivative equals 0. Okay, so if we're still talking about a derivative, so we're still talking about mean value theorem. But in order for the slope to be 0, we would need to have two equal y values. You only get a slope of 0 if you have two y values that are the same. Okay. C says f has a minimum value on the closed interval. So that would be like an EVT question. And f has a maximum. So that would also be EVT. Right, so let's look at the conditions of the problem. It tells us that we are both continuous and differentiable. So for mean value theorem, general mean value theorem, we are good. For EVT, we're continuous. So the one that we're having difficulty with is B, and that's where the specific slope of 0. We do not know if this function has two equal y values, so we do not know if the derivative will ever be 0. So our answer for this guy would be, which one could be false? B could be false. All right, let's look at another one. It says let g be a continuous function on the closed interval from 0 to 1. G of 0 is equal to 1 and g of 1 is equal to 0. Which of the following is not necessarily true? Okay, again, I would read through all of these options as answers and try to identify what they're actually referring to. So for A, it says there exists a number h such that g of h is greater than or equal to all of g of x. So this right here is saying that there is a maximum, an absolute maximum. For B, it says for all A and B, if A equals B, then g of A equals g of B. This is just the definition of a function. It's not actually a theorem that we're learning in AP Calculus. That's just the definition of a function. C says there exists a number h such that g of h is equal to 1/2. Now this is just a y value, so that would be referencing IVT. D is the same type of question. It's just a different y value. So still IVT. And for H, it says for all h in the open interval, the limit as x approaches h of g of x is equal to g of h. Sorry. That is just the definition of continuity. Okay, so now that we know what we're dealing with, we can look at the conditions of our question and see which of these have to be true, or more importantly, which does not have to be true. Okay, so we know our function is continuous. Well, if a function is continuous, then E is definitely true. And we also have a maximum. EVT says we have a max on any function that is continuous. And we are dealing with a continuous function, so that one has to be true. So it has to be one of these other two options. either C or D? Well, IVT says you have to obtain all of the X or all of the Y values between any two given Y values. And we have given Y values of 1 and 0. So we have to go between all of the Y values between 0 and 1. And 1/2 is on that interval or between those two values. 3/2 is not. So D does not have to be true. All right, we have time for one of the very last problem is one for you to try on your own. We'll have our last Zoom poll for the day. Take a minute and see if you can do this one.
All right, we'll take about 30 more seconds here. All right, here are the results.
Okay, so we definitely need to talk about this one because I have the correct answer being B. So let's look what they have to say. A says there exists a number such that the Y value is 0. So this would be an IVT question. B says the derivative is 0. So this would be a mean value theorem question. But in order to get a slope of 0, we need 2 equal Y values. C is an IVT question again, because it's just a Y value of 3. D is a slope of 3, a derivative, so that would be MVT again. And E says that there is a maximum, which would be like EVT. Okay, so looking at the conditions of this question, it tells us that our function is continuous and differentiable. So if our function is continuous, we definitely have a maximum. We're able to apply IVT and MVT. We just need to make sure our other conditions are met. So if we look for IVT, we have a Y value of -5 and a Y value of 4. So we definitely do have to go through 0 and 3. So both of the IVT ones would be true. So the question would be, which MVT is false? So let's go ahead and calculate the slope and see what is true. So I would do f of 1 minus f of -2 over 1 minus -2. So for this problem, that would give me 4 minus -5 over 1 plus 2, or 9 over 3, which is equal to 3. So our correct answer would be B, because it's asking which is not necessarily true, which could be false. All right, guys, so that finishes up my content for today. I do have the dates of the next review sessions as well as the topics on this last slide if you would like to take note on those and to sign up for those.
Thanks, Danielle. I'm actually going to go ahead and share my screen here for a second. It's got those same topics on there, though.
Yeah. Do you need me to stop sharing?
Nope, I think you're good. So again, you should see the screen over there. Yes.
Yes.
All right. So yes, thanks, Danielle. I think you did a really good job. Today's recording will be posted on our Bitly website after it gets uploaded. Should be in a day or two. Please make sure if you have a question for Danielle, shoot her an email. Her contact information is on the screen, as well as if you have any questions for myself, contact information is up there. March 6th, so it's a quick turnaround, but next week's session is functions and their derivatives, accumulation, and the fundamental theorem with Mark Crawley of AP Daily and College Board. So please make sure to tune in. We are excited to have him, just as we've been excited to have all of our presenters so far. So we'll hang out if any of you have any questions. If not, have a good rest of the day. And Danielle, thanks again.
Thank you.